everyone and welcome. In this video, we'll walk through how we built a retrieval augmented generation pipeline using two powerful tools, FireCrawl and Moorcheh. This setup allows us to scrape web content, chunk it, upload it to a vector database, and query it using an LLM. Let's talk about two specific tools used in this demo. So firstly, let's talk about Moorcheh. Moorcheh is a vector database optimized for semantic search and generative answering. It supports namespaces, metadata filtering, and getting generative answers. FireCrawl is the web scraper that we use in this demo. It returns clean markdown or structured content ideal for RAG pipelines. In order to access all the code that we're using in this demo, you can visit the Moorcheh.ai examples GitHub page. So whether you're a product developer, technical writer, or just curious about AI, this demo shows how vector search and web scraping can turn abstract ideas into clear, contextual answers, all from real-world content. Let's get started.
To show off our code, we pasted it into a Google Colab. So to start, we're going to install all of our necessary packages, and this includes FireCrawl PY, as well as Moorcheh SDK. Then we'll be importing all of the necessary packages that we'll be using in this pipeline. And next we have the preparation variables set up. So we're going to set up the logging, and we're also going to set up the FireCrawl API key, as well as the Moorcheh API key, and this will be done through the secret variables in Google Colab, as shown here. This will also search to see if these keys are not set, and if they aren't, it will raise an error. Next, we're going to initialize our clients. So we're going to initialize the FireCrawl app as well as the Moorcheh clients. Next, these are just some config variables, and this is needed for creating the namespace. So first we have the namespace name, followed by the namespace type, which is set to text, but you can set it to vector if you like to upload vector embeddings. And we also have the vector dimension set to none because it is a text-based namespace. For a vector name namespace, you would write the integer, which represents the dimension of the vectors. We also have the query CSV path, and this will specify the file that holds all of our queries that we're going to ask Moorcheh. We also have the output CSV path, and this will be the name of the file that will hold all of our answers. Next, we have a list of all of the web pages that we'll be scraping for information, and we'll be uploading these documents into our namespace. And finally, we specify the AI model, which is Anthropic Cloud 3.7 Sonnet. And this is the AI model we'll be using to answer some of our questions as an LLM. So before we move on, let's look at the URL that we're going to be scraping. So we're actually going to be scraping this about page from Moorcheh. And this is essentially a page that talks about our mission statement, why we created Moorcheh, and what is the purpose of the company. Essentially, we'll be asking queries about this page to get a better understanding of what Moorcheh is really all about. So next, we have the scraping and batch uploading functions. So we'll scrape the URL and we'll chunk it into chunks, and then we'll upload those chunks in batches into our namespace. Next, we're going to create the actual namespace, and we'll have the namespace name, namespace type, and vector dimension as specified before. And we'll also specify the clients that will upload in batches, as well as the namespace name. And we'll also set the batch size to 100 chunks.
Next, we're going to run the queries. So in order to run the queries, firstly, we're going to read our queries.csv file. As you can see in our queries.csv file, we have several questions related to conceptual understanding about Moorcheh. So going back to our function, we can see that we go through each query, and for each query, we make a call to Moorcheh client or Moorcheh SDK for getting the generative answer. And in this case, as mentioned before, we use the AI model Claude 3.7. And then we write these answers to an answers.csv file. As you can see in the answers.csv file, there are 3 rows, one with passage ID, and the query, and then the generative answers. With these answers, we found that the generative answers were long, coherent, and grounded in the script content, indicating that the accurate data was obtained from the Moorcheh website.
So to wrap up, this RAG pipeline showcases how semantic search powered by Moorcheh and ingestion by FireCrawl can deliver accurate, context-aware answers. So I'd like to thank you for watching our demo, and we hope to see you use Moorcheh in the future. Thank you.